Hi guys, welcome back to another video. Today we're going to be solving chapter 8 from the course question document. So let's begin. Give the electron dot diagram for each of the following chemical species. So I'm just going to do a few of them and so you're able to practice the rest by yourself to make sure that you understood the topic. So I would start with part B, HF. Okay, so hydrogen has one electron. Fluorine, since it's in group 7, it has 7 valence electrons. Okay, so I'm going to draw hydrogen around it a circle and fluorine around it a circle. Now for hydrogen, it's going to be a circle, while for fluorine, I'm going to put X. So since we have 7 valence electrons, so 1, first we're going to fill them all up. 2, 3, 4, 5, 6, 7. And then you guys can see they share a pair of electrons in order to form HF. And that's it. Let's look at part D. So nitrogen and hydrogen, NH3. Nitrogen is in group 5, so we have 5 valence electrons. Hydrogen, 1 valence electron. So the total number of electrons is going to be 5 plus 3 times 1, because we have 3 hydrogen atoms, 8. So let's draw it again. N, and then a circle. Then I have H, H, and H. Now for nitrogen, I need 5. So nitrogen, I'm going to put it as an X. 1, 2, 3, 4, 5. Hydrogen, 1 for each. 1, 1, 1. And again, we can see them sharing a pair of electrons. Okay, you see how here they're sharing a pair of electrons, so it's going to be a covalent bond. Now let's look at a different example. For example, MgCl2. Okay, now MgCl2 is what? We have a metal plus a non-metal. When we have a metal and a non-metal, we call it ionic. Okay, we have ionic bond, we have an ionic compound. So how are we going to do this? Remember, ionic bonds is loss and gain of electrons. Okay, so one atom will lose the electrons while the other atom or other element will gain electrons. While in covalent bonds, what did we say in covalent bonds as we saw in the examples we just did? They share electrons. Okay, so let's look at it now. Mg is plus 2 because it's in group 2, and we have Cl minus 1, but we have 2 chlorine. So since Mg, I'm gonna first draw Mg by itself. Mg is in group 2. So what I would normally do is put 2 electrons. But remember, it's 2 plus, okay, or plus 2, 2 plus. It's going to lose 2 electrons. So these 2 electrons, it's going to lose them, and they're going to be gained by who? By the chlorine. So I have Cl, Cl, I have 2 chlorines. Okay, chlorine is group 7. So I'm gonna put 1, 2, 3, 4, 5, 6, 7. And then again 1, 2, 3, 4, 5, 6, 7. Now what's going to happen? Mg will lose 2 electrons while each chlorine atom will gain 1 electron. So this will go here and then this will go here. So what will we have? We will have Mg 2 plus, and we're going to have chlorine, 2 chlorine atoms. This is just going to be again, okay, because we have 2 chlorine atoms and they're going to be the same. Let's do one more. We'll do the last one. Or you know what? Keep the last one as an exercise for you guys to try to do it by yourself. Let's move on. Define a dative coordinate covalent bond. Okay, so this is another type of a covalent bond where this covalent bond we only have one atom is contributing the pair of electrons to bond with the other atom. So as we saw in these examples, HF for example, hydrogen was sharing one of its electrons and fluorine was sharing another of its electrons. But when we look at a dative coordinate covalent bond, it will be like NH4 plus. Okay? This is one example of coordinate covalent bond. Another example would be hydronium ion, so which is H3O plus. And one more example would be NH3BF3. So know these three examples for dative covalent bond. Okay, so we have to draw the cross dot diagram for O2, C2H4, and N2. So before, let's look at what this section is going to be talking about. This section is going to be talking about double bonds. Now, as you guys know, we have single bonds, and in single bonds, we only have one pair of electrons being shared. Okay, that makes sense. Now, double bonds, what do you guys expect? Of course, it's going to be two pairs of electrons being shared. Now, we also have triple bonds, and this is going to be how many pairs? 3 pairs of electrons being shared. So let's look at the examples. I'm going to do C2H4 and N2. Let's start with C2H4. So we have carbon, carbon. Okay? Carbon is going to be dark. For this carbon, I'm going to put it in dark blue. Carbon is found in group 4, so it has 4 valence electrons, and I'm going to denote it as an X. So 1, 2, 3, 4. Now there's going to be a hydrogen atom and a hydrogen atom. It's going to be a circle. So this here, they're sharing this pair of electrons. They're forming a bond and a bond. Now the same thing for the other carbon. I'm gonna put it in purple, and I'm gonna denote it as circles though. So circle here, 1, 2, 3, 4. Again, I have 2 hydrogen atoms with 1 electron. We have 1 bond, 1 bond. Now, what do we see? In the middle between the 2 carbon atoms, we see 2 pairs of electrons being shared. That's why here we're going to have a double bond. Now let's look at nitrogen. Nitrogen is in group 5, so I'm going to have 2 nitrogen atoms, and they're going to be surrounded each by 5 valence electrons. So let's put 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you guys can see we have 3 pairs of electrons being shared. This is 1 bond, another bond, and a third bond. So nitrogen, this is how we draw it. It has a triple bond. Try to do oxygen by yourself just as extra practice. Let's look at number 7. Draw the electron dot diagram for CO2. They're asking us for the shape of CO2. Does it have polar bonds, and is it a polar molecule? So again, it's all going to be the same process how we're going to solve such type of questions. Oxygen is group 6, so I'm going to put 6 electrons. 1, 2, 3, 4, 5, 6. Again, 1, 2, 3, 4, 5, 6. For carbon, I'm going to put them as X. 1, 2, 3, 4. Now the reason why I put them here because I want them to form a bond with oxygen. And you guys can see this is a bond, this is another bond, this is a bond, this is another bond. So carbon and oxygen are bonded by a double bond. This is the electron dot diagram. So we did part A. What is the shape of CO2 molecule? Now, the shape of a CO2 molecule is going to be linear. Now, why is it linear? Because it has sp hybridization. And how did I know it has sp hybridization? You just look at the regions. So sp, it has two regions around it. I look at carbon, it's surrounded by one region and another region. That's why it's two regions. So sp and the shape of sp hybridization will be linear. Does it have polar bonds? Now polar bonds form when we have a difference in electronegativity, and this is how we draw the polar bond. So we have two polar bonds. However, if you guys can notice, they're both going in opposite directions, and we learned from physics, two forces, same magnitude, opposite direction, they're going to cancel each other out, and this is exactly what happens here. So is it a polar molecule? No, but it does have polar bonds. It's not a polar molecule because they cancel out. Okay, perfect. Let's look at number 8. Arrangement and movement of particles in solid, liquid, or gas are explained by the kinetic theory. At room temperature, chlorine exists in the gas state. Give the electron dot structure of a chlorine molecule. Again, chlorine is found in group 7. So I'm going to put Cl, Cl, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And here they're going to share this pair of electrons. This is the electron dot diagram of chlorine. Compare the movement and arrangement of chlorine molecules in the solid state to those in the gas state. Now, if we're going to look at the pattern in the solid state, it's going to be in a regular pattern. While in a gas state, of course, it's going to be random because they are found, they're going to be extremely spread out from each other. So, just an example for the gas, this is what they're going to look like. Their pattern is random. However, in a solid, they're going to be in a lattice structure. Okay, they're going to be close to each other. Now we're going to look at the distance. They're going to be close. While in a gas, they're going to be far from each other. And finally, the movement here. How do molecules or particles move in a solid state? They just vibrate. Okay, because since they're all compacted together, they cannot really move. So you just see them vibrating in their place. So they vibrate in their fixed position, while in gases, of course, they're going to be freely moving. Okay, let's look at part 3i. The pressure inside increases with temperature. Now, why does the pressure increase with increasing temperature? Let me give you an example. If I have a container and I have particles or molecules in this container, okay? Now these particles and molecules will be hitting the walls of the container, okay? If I increase the temperature, what happens when I increase the temperature? The kinetic energy will increase. So when I say the kinetic energy increases, that means the speed these particles are moving is going to be faster. So they're going to be moving faster than before. So since they are moving faster, they are more likely to hit the walls of the container, and as they hit the walls of the container, what's going to happen? The pressure is going to increase. Okay, now we need to use the following table. Why hydrogen chloride diffuses faster than chlorine? So again, this is, if we want to think about it logically, something that is heavy will not move as fast as something that is light. So let's look at the molecular weight. So chlorine is going to be Cl2, it's going to be 71. Hydrogen chloride will be 1 plus 35.5, so 36.5. So of course, Since hydrogen chloride has a smaller molecular weight, the molecules will move faster. If temperatures increase, both gases diffuse faster. We already mentioned, as temperature increases, kinetic energy increases, and remember kinetic energy, the formula was half mv squared, this is velocity, so that's why they are going to move faster. Compare the rate of diffusion of carbon dioxide gas to that of chlorine and that of hydrogen chloride. Carbon dioxide gas, the molecular weight will be 44, so it's going to go second in place. We already said hydrogen chloride first in place, and the slowest would be chlorine. And okay, we still have number 9. Okay, they're telling us to show the outer shell electrons only. Whenever they say outer shell electrons only, we are talking about the valence electrons. And how do we get the valence electrons? By the group number. So carbon is going to be group 4, so it's going to be surrounded by 4 dots. Hydrogen, only 1, I'm going to put it as an X. And again, this is the bond that's going to be forming. Now oxygen, I'm going to put it in blue, is group 6. So 1, 2, 3, 4, 5, 6. Now the reason why I didn't put it here, because I know that it has to form a bond with hydrogen, and if there are 2 electrons of oxygen here, it cannot form a bond with hydrogen. And then hydrogen, of course, has 1. I'm going to put it as an X. Again, we have a bond here, and we have the bond here. Same thing for this. I'm going to keep it for you guys as an exercise to do. If you find difficulty, just let me know in the comments down below. And that's it for chapter 8. If you guys want me to solve chapter 9, let me know in the comments down below. Thank you all for watching. Best of luck and see you soon.